Hello everybody, let's talk about section 3.3, which discusses the zeros of polynomial functions. And in this section, we're really only going to be covering the following: multiple zeros, the concept of multiplicity, the rational zeros test, Descartes' rule of signs, named after René Descartes, and zeros of a polynomial, how we find them. The whole point of this particular chapter, at least in the first few sections, is the idea of being able to find the zeros of a polynomial function. And how do we go about it when it's not easily factorable? Our rules here and some of these definitions are designed to help us discover where those zeros might be and allow us the ability to find zeros where we might not otherwise be able to. So we're just going to go over a few of these techniques. But first, a definition: multiplicity. What does that mean? Well, multiplicity of a function really means how many times a zero or a factor would repeat. And we define it this way. We say if p of x has x minus c raised to the power k as a factor, then we would say that x equals c is a zero with multiplicity k. What does that mean? Let's take a look at p of x right here. P of x is partially factored. Let's go ahead and finish off the factorization of this function. So p of x is going to be equal to, let's see, x squared minus 4. We know how that one factors. That factors as x plus 2 times x minus 2. And of course, x plus 3 squared means x plus 3 times itself twice, right? So if we actually were to break this apart, let me straighten that out a little bit. If we were to actually break this apart into its completely factored form, we would find that we have a fourth degree polynomial. And if you remember back to our last video, that indicates that we would have some specific kind of left-hand, right-hand information. Not only that, but that the x plus 3 repeats itself twice. Because it's a power 2, we know that if we were graphing at the point negative 3, 0, we would have one of those points where the graph intersects but does not cross the x-axis. So where are our zeros? Well, we find our zeros by setting p of x equal to 0 and finding the values of x that make that true. I won't go into the entire setup here, but we know that x equals negative 2 is a 0. So we would say p of x equals 0 at x equals negative 2. That's a solution. So is x equals positive 2. But so is x equals negative 3. Now it repeats itself twice, so rather than having to say x equals negative 3, x equals negative 3, which would be kind of silly for me to be rewriting the whole thing, what I'm going to do is I'm going to abbreviate it and say m2 to stand for the fact that we say x equals negative 3, negative 3 is a 0 of multiplicity 2. All right. So that's actually not a hard thing to understand, the concept of multiplicity. Let's see if I can spell it better here. But multiplicity simply indicates how many times a factor will repeat itself. And incidentally also gives us some information about the way that the function will act at x equals negative 3. So if we were interested in factoring and graphing this function at this point, we know that what we would get is a graph that would have a positive leading coefficient and be of fourth degree, so it would go up to the left and go up to the right, and would pass through the x-axis at negative 2 and negative 3, and at positive 2 as well. and that at x equals -3, it would have the kind of behavior where it came down and touched the x-axis but didn't cross through. It would cross through the x-axis at -2 and then cross back through the x-axis at +2 again. And so this would be some information that might help us if we were trying to graph what this function actually looked like. Okay, more to come in the next video.